So in the previous class, so I said about abstract classes and abstract methods. So when you declare as an abstract class is, I said no, abstract class is used for developing similar type classes. Okay, abstract classes are having abstract methods. Okay, what is abstract method is so method which is declared with at the rate abstract method, that you call it as abstract method, right? So abstract method doesn't have implementation. Abstract method doesn't have implementation within the same class, because implementation changes from one class to another class. Not having implementation in the same class, that implementation changes from one class to another. So that you can call it as abstract class. So what you can do here is, a simple example, if you see, so when you go for abstract classes, so for example, there's a class called triangle. For example, there's a class called which one? Triangle. Triangle is a class. And what triangle is having is, so triangle is a class and triangle is having two dimensions. So triangle is having two dimensions. So that is the dimension one, and one more is what here, dimension two. So triangle is having two dimensions. So that is the dimension one and dimension two. So here, now you read the dimensions. Okay, you read the dimensions of the triangle by using one method called read. So read is a method using which you are trying to read dimensions like self dot dimension. So you are reading dimension one. Okay, so this is a dimension of which one here? So we are trying to read dimensions of, okay, triangle. So float of input. Okay, so there are two dimensions for the triangle. So you are reading the dimensions of the triangle. And there is also one method called find area. See, find area is another method. And this method will return Okay, dimension 1 into dimension 2 into 0.5. So that is nothing but half into base into height. Okay, so that will return the area of the triangle. So that will return the area of the triangle. So there is another type. Okay, so there is another type. And what is it? Another type here you have is rectangle. So there is a triangle and there is also what here? Rectangle. So what rectangle is having two dimensions? That is a dimension 1 and one more is what here? Dimension 2. So triangle is having two dimensions and rectangle is also having two dimensions. Now you are reading the dimensions of the triangle by using what here? Read. Again, self dot dimension. See how you are reading it. So you read the dimensions of triangle and self dot dimension 2. Again, you are saying float of input. You read the dimensions of rectangle and there is a find area which finds an area of the rectangle. So where you are saying return. Okay, self dot dimension 1 into self dot dimension 2. Okay, self dot dimension 1 into self dot dimension 2. Okay, so if you see this, now this both are having same properties. Okay, so triangle is having how many properties? Two properties, and rectangle is also have two properties. The way how you are reading the dimensions of triangle, in the same way you are reading the dimensions of what? Rectangle. The way how you are reading the dimensions of triangle, right? In the same way you are reading the dimensions of rectangle. Okay, so when more than one class share the same properties, you write those things how many times here? One time. And use it how many times? More than one time. Okay, you try to use that how many times? One time. And you're trying to declare. So that is reusability, right? You're trying to write those things how many times? One time. And you're trying to use it how many times? Number of times. So what will I do is I develop one class. What is the name of the class here? Shape. Okay, now I'll try to define what are the properties of the shape. So I said every shape is having two dimensions. That is dimension 1 and one more is what? Dimension 2. Every shape is having two properties. One is a dimension 1 and one more is a dimension 2. Two dimensions. Dimension 1 and dimension 2. And you're trying to read the dimensions. You're trying to read the dimensions by using which one? A read dimension. So I'm trying to write this code how many times? One time. So where I'll say self dot dimension 1 equal to float of input. Okay. So input the dimension 1, self dot dimension 2 equal to float of input. You're trying to read the dimension 2. So you're trying to write this code how many times here? One time. And you're trying to use this code how many times? Two times. Means you will try to use the same code. You'll try to use the same code in which one? Triangle as well as what? Rectangle. So I don't declare. Now I don't declare this dimensions. I don't declare these dimensions. You don't declare the dimensions. And you don't declare this read also. because this code is written how many times here? One time. So now triangle. So triangle inherits shape, and rectangle also inherits what here? Shape. But if you see this triangle and rectangle, so this triangle and rectangle is having a method called find area. This triangle and rectangle is having what here? Find area. But if you see this find area, if you see this find area, so method name is the same, but implementation is what? Different. Okay, every shape is having find area. So method name is the same, but implementation is what here? Different. Method name is the same, but implementation is a different. Method name is the same, but implementation is a different. Then you write how many times? Okay, then you declare this. You declare this how many times? One time. You declare this how many times here? One time. Declare. Declare means without body. I'm saying here every shape is having. Now this is rule. Every shape is having one method. Every shape is having one method. What is that method? Find area. But is it find area definition is implementation is the same? No. The find area implementation is not a same. It changes from one derived class to what? Another. It changes from one derived class to another, right? So that implementation is not same. The implementation changes from one derived class to what? Another. See. But every shape is having this. Which method? Find area. Every shape is having find area, but the implementation is not same. Okay, it means now triangle inherits two dimensions and three dimension as well as what? Find area. You are saying that okay, every shape is having two dimensions and three dimension as well as what? Find area. But you are saying that okay, you must implement find area, but the implementation of this is not the same. It changes from one shape to what? Another shape. Then you declare this method as what? Abstract. But you can write an abstract method only in which class? Abstract class. You can write an abstract method only in which class? Abstract class. You cannot write an abstract method in non-abstract class. You write an abstract method only inside which class? Abstract base class, right? But how can you create that abstract base classes? Now we'll try to develop this. So how can you create that abstract base class here is? So for implementing this, you have to import ABC class. So the class which implements, the class which inherits ABC class. What is this ABC here? Module. And what is this ABC here? Class. So the class which inherits ABC class is called abstract base class. Now the class which inherits ABC class is called abstract base class. So there is a dimension 1. Okay, there is a dimension 1 and there is a dimension 2. So I declare this as a now protected. See, only one underscore means protected. This tells that you can use this only in which class? Derived class. Now predictors are accessible only in derived class. Now here I declare it as only protected. Protected means only one underscore. Private means how many underscores here? Two underscores. And if you don't put underscore, then it is a public. Now protectors are accessible only in which class? Derived class. Protectors are accessible only in derived class. Okay. Now here I'm saying, yes, read dimension. So read dimension is a method where I'm saying, so dimension 1 equal to float of input. Input, what is that? Dimension 1. So dimension 2 equal to float of, so input dimension 2. So you are trying to input how many dimensions here? 2 dimensions. That is dimension 1 and one more is what? Dimension 2. So ABC dot, I'm saying here abstract method. Now there is a method called find area. So this method, I declare it as an abstract here. Now this is an abstract here. So this method is declared as what here? Abstract. Okay, why? Because is it implementation of this method is the same or different? Different, right? So class, there is a class called which one? Triangle. Triangle is a shape, and override. Override which method? Find the area. Return self dot dimension 1 into self dot dimension 2 into 0.5. So there is a class rectangle. So there is a class rectangle is also what here? Shape. So your triangle is a shape and rectangle also what is that here? Shape. Now here I am saying return self dot dimension 1 into self dot dimension 1 into dimension 2. Self dot dimension 1 into dimension 2. So I try to create how many shapes here? 2 shapes. So this is how it is. Now this is a function main. This is a function main where I'm saying triangle 1 equal to triangle, rectangle 1 equal to rectangle. Suppose if I'm not overriding this, if I'm not overriding this method in triangle, if I'm not overriding this method in what? Rectangle, then it generates error. Because the class which inherits abstract class must provide the implementation of all abstract methods. The class which inherits abstract class must provide the implementation of all abstract methods. Must provide the implementation of all abstract methods. Must provide implementations of all abstract methods. Now you are saying read dimension. Okay, R1 dot. Again, I'm saying read dimension. So I read the dimensions of triangle. I read the dimensions of what? Rectangle. Area 1 equal to T1 dot find area. Okay, area 2 equal to R1 dot find area. So this is area of triangle. I just print area 1. So this is print area of rectangle. I print what here? Area 2. So this is what will happen when you work with the frameworks. So frameworks provide abstracts. For example, if you are working with Django, they'll provide an abstract called model. Now, whenever you want to develop a model, you just inherit which class? model class. Suppose student model, employee model. Student model is a model. Employee model is a model. Student view is a view. Employee view is a view. So who provide the abstracts? The abstracts is provided by framework. Okay. Yes. So once you run this, now these are the dimensions of the triangle, or this is dimension of which one? Rectangle. Now this is 0.78, but every class which inherits abstract base class must provide the implementation of all abstract methods. If you don't provide the implementation of abstract methods, okay, then it gives an error. Must override abstract methods. But what you can do by using these abstract classes and abstract methods, so using abstract classes and abstract methods, we can achieve runtime. Runtime, what is that? Polymorphism. We can achieve the polymorphism. We can achieve what here? Polymorphism. So here poly means poly means what here? Many. Poly means many, and morphism is what here? Forms. So defining one thing in many forms is called polymorphism. Defining one thing in many forms is called polymorphism. Example is method overriding. Example is method overriding. Okay, example is method overriding or abstract method. So the implementation of abstract method changes from one derived class to another. So defining one method in many forms. Find area is there. Implementation of find area varies from one derived class to another. Okay, so that is called as polymorphism. That is called as what here? Polymorphism. That is defining one thing in many forms. Defining one thing in many forms is called polymorphism. Okay, right? So this is how you are trying to do it. So defining one thing in many forms. So that you are saying it as what here? Polymorphism. Like example is method overriding an abstract method. So what is runtime polymorphism? What is runtime polymorphism? Or same thing you call it as duck typing. What is runtime polymorphism or duck typing? So an ability of a reference variable an ability of a reference variable changes behavior based on the type of object assigned. The type of object assigned is called runtime polymorphism. So an ability of a reference variable changes behavior based on the type of object assigned is called as runtime polymorphism. So this allows to develop loosely coupled code. So this allows to develop loosely coupled code. The code which work with any type is called a loosely coupled code. The code which work with any type is called a loosely coupled code. Which works with any type is called a loosely coupled code. An ability of a reference variable changes behavior based on the type of object assigned is called a runtime polymorphism. This allows developing loosely coupled code. The code which works with any type is called a loosely coupled code, which works with any type. So that you call it as which code here? Loosely coupled code. So the same thing, you are saying it as a duck typing. The same thing is called as a duck typing here. So what is a duck typing here is? The same thing is called as a duck typing. A programming style which doesn't look for, a programming style a programming style. What is a duck typing is? A programming style which doesn't look at an object's type to determine if it is right interface. Instead of that, method or attribute is simply called or used. If it looks like a duck and quacks like a duck, it must be what here? Duck. It looks like a duck and quacks like a duck. It must be what here? Duck. So it doesn't look for the type. If it is having same method, same attribute, it is similar type. It treated as similar type. It is treated as what here? Similar type. For example, there is an abstract class. So there is an abstract class called, for example, assume that. So there is an abstract class called sim. Sim is an abstract class. Okay, sim is an abstract. I just write import ABC module. What sim is having? Sim is having some number. Okay, so there are some properties of the sim. I take some number. Okay, I take some number. Okay, self dot number. Okay, self dot number. Number is there equal to number. Private I declare. Then set number. So this will assign value to, So there is a get number. This will return the number. So self dot number, and every sim is having one abstract method. It is having an abstract method. What is that abstract method? Is connect. Every sim connects to a specific network, but which network it connects, that might be various from one sim to another. Which network it connects, that might be various from one sim toward another sim. It will not be the same. It changes from one sim to another sim. Correct. So this is a connect. Now this might be various from one SIM to what here another SIM. For example, Airtel SIM is a SIM. It inherits all the properties of what here SIM. So where I'm writing super dot, which method I called init method. Then I provide the implementation of connect. I provide the implementation of what? Connect. And here I'll just display the message. Okay, so connected to what? Connected to Airtel network. Connected to which network? Airtel network. So there is another SIM called a Geo SIM. Okay, so this is how duck typing. I just taken simple example of duck typing. So call the init. So override. Which one here? Connect. So connected to Geo network, right? So connected to which network here? Geo network. Okay, so the class, and this is what your implementations. So the sims are used inside one class called which one? Mobile. So is it your mobile will work with one sim or any sim? Any type of sim. So within mobile, there is one method called insert. what you're inserting in this mobile SIM. But every SIM is having which one? Connect. Okay, every SIM is having which one? Connect. I just take SIM dot. I read the mobile number, SIM dot get number. Okay, because every SIM is having number, comma, you'll try to call S dot, what is that? Connect. So how many methods I'm calling here? Two methods. You are getting mobile number and you're also connecting to a specific network. So there is a class. Now there is a mobile one equal to mobile. So there is one mobile. So, and there is different SIMs. So there is a SIM one. SIM one is what here? Airtel with some number. Okay, with some number. Okay, SIM 2 is there with Geo. Airtel SIM 2 is there with the Geo, and this is number. So mobile one dot insert. I'll try to say SIM 1. So what will happen if I say mobile one dot insert SIM 1? So it will send a which SIM here? Airtel SIM. Then is it Airtel SIM is having get number or not? Yes. Because Airtel SIM is inherited from which class here? SIM class. So get the number of that and it will display the message. S dot connect means it will display connected to which network? Airtel network. Suppose if I change it, okay, if I change the network, I mean SIM from, now if I change the SIM from, okay, if I change the SIM from, now if I say this, oh, we have to send a mobile number, right? Okay, so this should receive number, and that number you have to send to which class? Super class. So this should also receive number and that number should be sent to super class. Now connected to which network here? Airtel network. Okay. Then get number return self dot number. Receive the number and call init method of which class? Super class. But what happened to the second one? Okay. So second, so it is bind with S dot get number. So this will return the mobile number. So connected to Airtel network, and this is a message. So actually I should not say connect here because this will not return any value. Actually, this will not return any value. I have to call this individually. I have to call this method individually saying as dot connect. So you can see this is a number and connected to which network? Airtel network. But what will happen if I change the SIM? Mobile one dot insert. If I change the SIM from SIM 1 to SIM 2, now this S is holding which object now? SIM 2. But SIM 2 is which type of SIM here? Geo. Then it will get the number of this Geo SIM and then connected to which network? Geo network. So this is a mobile number and connected to which one? Geo. So this code, now this you call it as duck typing. Duck typing. This is called as a duck typing here because it doesn't look for the type. It just look for whether it is having similar methods or not? Any object which is having get number and connect, any object which is having get number and connect, any object which is having get number and connect, so that is treated as what? Any object which is having get number and connect, so that is treated as a get number and connect, so that is treated as, okay, that is treated as what? Sim. Any method which is having get number and connect, that is treated as a sim. So it doesn't look whether it is a proper type or not, but you just call it proper type or not, but you just call it. Okay, so that you can call it as duck typing. So is it this code will work with any sim or not? Yes. Suppose in future there is one more sim. Is it able to work this code or not? Yes. Now this is how APIs are developed. This is how APIs are developed. So when you're talking about API, there is an abstracts, there is a implementations, and there is a caller. So caller calls implementations, caller call implementations using interface. Now this you can call it as API, application programming interface. It means mobile is calling the functions of SIM. Mobile is calling the functions of different types of SIMs. Mobile is calling the functions of different types of SIMs by using which interface? SIM interface. Who's a caller here? Mobile. Who's a caller here? Mobile. So it is like that. So loosely coupled. So that is what you mean by loosely coupled code. So that is called as an abstract classes and abstract methods. Okay, abstract classes and abstract methods. And that is how you achieve runtime polymorphism. Now let us see. So let us see nested classes. What is that? Inner classes. Let us see nested classes, or what is that? Inner classes. Nested classes. So a class inside a class. If you are writing a class inside a class, so defining a class inside class is called nested classes. Is called nested classes, or it is called as which one? Inner class. Inner classes. Nested classes are inner classes. A class inside a class, or a class inside class, is called a nested class. Is called a nested class, or the same thing is called which class? Inner class. A class inside class is called a nested class, or it is called in inner class. So why you write a class inside a class? Okay, why you write a class inside a class? Now, if you're writing a class inside a class, so that can be called as inner classes, or that can be called as what here nested classes. If you are writing a class inside a class, so that can be called as inner class, or that can be called as which one? Nested class. So this is syntax. Now, why you write a class inside a class? So what is the need of? Okay, need of inner classes. Inner classes are nested classes. What is the need of inner classes or nested classes? So the advantage of using inner classes or nested classes. What is the need of this inner classes or nested classes? So generally uses inner classes or nested classes. Okay, why use this nested classes is, one is hiding implementation of classes. Hiding implementation of class. You want to write a class and you want that class should be used by only one class, but it should not used by any other class. Then you write a class inside a class. Then you write a class inside a class, right? So hiding implementation of a class, and second one is, okay, second one is reusability. Anyway, reusability. You want to write a class whose implementation is used by only one class. Only one class. Right now, what is the syntax of writing inner class? See, inside a class, you can write a class anywhere. For example, class, you'll write class and it followed by class name. And class, it followed by what here? Class name. So class name. Now this class is called which class here? Outer class. So within this class, you are writing which class here? Inner class. So this you can call it as inner class. The same thing is called what here? Nested class. And in this you write a variables and methods. And in outer class also you can write variables, and in outer class also you'll write some variables and methods. You write variables and methods in outer class. You write variables and methods in what? Inner class. You write variables and methods in outer class. You write variables and methods in what? Inner class. Okay, so this is the inner class, right? An inner class performs. Inner class can perform operations using members of which class? Outer class. So this inner class is there, no? This inner class can perform the operations using the members of which class here? Outer class. So inner class can perform the operations using the members of which class? Outer class. But outer class cannot access members of inner class directly. But inner class can access members of outer class. Members of outer class, what here directly. So inner class can access the members of outer class directly, but outer class cannot access the members of inner class directly. So what is the meaning of this is, for example, if I write a class, so there is a class A. So there is a class A is there. So within class A, so what I'm doing is I'm writing one method. Sorry, within class A, I write another class. Okay, class B. Now inside class A, I write class B. So class A is called which class here? Outer class. Class A is called outer class and class B is called which class here? Inner class. Class A is outer class and class B is which class here? Inner class. So two classes are there. One is outer class and one more is what here? Inner class. So within class B, I write M1 method. So this is instance method or object level method. M1 of which class here? B class. M1 of which class here? B class. So how can I access this B class here? So I can create object B equal to A dot B. A dot B means A is which class here? Outer class. And B is which class here? Inner class. Means I create object of B class outside which class? A class. Okay, and then I'm saying OB is a B dot M1. OB is a B dot M1. So once you run this, you can see M1 of which class? B class. But I don't want this B class should be used outside. Then I make this B class as what here? Private. So if it is a private, can you able to access it? No. Now this inner class can be again. This inner class can be again public, or it can be a private, or it can be what? Protected. If you want this class B should be used only inside A class, then declare that class B as what here? Private. Then declare that class B as what here? Private. So that I can use that class B only inside which class? A class. Okay, I can use that class B only inside A class, but not outside the A class. Only in A class, but not outside the A class. For example, like in application development, see, wherever you want, you write the class. Inside a class, you can write a class anywhere. You can write a class inside a method. So if you're writing a class inside a method, then it is called local class. Okay, you can write a class inside a method. Then if you're writing a class inside a method, then it is called as a local class. Means that class is used only inside a method. If you write a class inside a class, that class can be used anywhere within the class. So wherever, whichever method the class want to access it. Whichever method want to access that class, access it. Now that is how you are providing different implementations of those classes, right? So there is a class. So what is the name of the class is? There is a class called person. Within person class, I write one private class. What is a private class here? Address. So where I can use this address class? I can use this address class only inside which class? Person class. I can use this address class inside which class? Person class. But I cannot access this address class outside the person class. I cannot access this address class outside the person class because is it this class is a private or not? Yes. Okay, this class is a private. So I can use this class only in the person class, but not outside the person class. So what address is having? Okay, address is having some properties. So what are the properties of address? Like address is having a street and address is having what here? City. So there is a read address is a method which read. Okay, what it reads here? Street. So where I'm saying input, what you have to input here? Street, input street, and then you have to input what here? City. Input street and input what is that? City. And there is a print address, and they should print what here? Address, format, self dot. So what I'm doing it self dot the street and self dot what is that? City. So there is a person, and what person is having? So person is having name. Person is having what here? Name. And person also have what here? Address. But where is the address class in? Address class is there inside which class? Person class. So it means where I'm using this address only inside a person. Now there is a read. So where I'm trying to read name of the person, input name, okay, input name and self dot address dot read address. Okay, now we try to develop a address class, but where I can use this address class only inside which class? Person class. But I cannot use this address class outside the person class because this is inner class and at the same time it is what? Private. So there is a print. There is a print person. So this print the details of a person, like what it prints here is format. Okay, now self dot. Self dot, what is that? Name. So print, okay, format. Okay, self dot. Okay, self dot address dot. So we can print directly, right? Why 2 times? Self dot address dot. What is that? Print address. So this is writing a class. This is writing a class inside a class. So person one and person one dot read. Person one dot print. Print what is that? Person. You are reading the details of a person. You are printing details of what here? Person. So once you run this, now it's asking to input the name. Name is Naresh. And this is a street. And this is what here? City. Oh. So what is the name of this? Street. Underscore. So I try to enter the name of the person and this is a street. And this you can call it as what here? City. But where we write this address class only inside a person, but where we can use this address class only inside the person. So this is which class here? Outer class. And this is called as which class here? Inner class. So wherever you want, you can write a class. Wherever you want, you can write a class. Inside a class, anywhere you can write a class. So the rules like local means it is used only inside a method. If you write a class inside a method, then that is called as which class? Local class. Means where local class is used only within the method. Local class is used only inside a method, but local class can you access outside? No. So local class is used only inside a method, but local class is not accessible where? Outside the method. Okay. Now this is how you write a class inside a class, and writing a class inside a class is called which one? Nested class or inner class. Tomorrow onwards we'll start another chapter, that is exception handling. Tomorrow we'll start exception handling, right? So remaining are simple things are only like exception handling, regular expressions, files, networking, multi-threading. All these are simple topics. Okay. So tomorrow we'll see working with exception handling, right? So thank you. We'll see tomorrow.